Hi everyone. Let's take notes on lesson 6.1, the polygon angle sum theorems. Alright, so let's look at the explore and reason. So you're encouraged to pause the video and read through the explore and reason, then come back and check your exploration. Okay, below the pentagon, draw a line by extending the side. Okay, so we're going to draw a line here. Extend the side. Okay, draw a line here, extend the side. Okay, and then choose one pair of lines that intersect. So there's a pair of lines that intersect at the vertex of the pentagon. Is each of the four angles formed at the vertex an interior angle or an exterior angle of the pentagon? Okay, well, if you notice, we have, so focusing just on the two diagonals at one vertex, we have one interior angle, okay, one interior angle, and then we have three angles on the outside of the pentagon. Okay, the exterior angles, there's three of them. Okay, the next question, are the relationships the same for these angles formed by the other pairs of intersecting lines? Yes, if I extend this line, then the same thing happens. We get one, so if I extend this line, we get one interior angle, and then we get three exterior angles, and that's true for all of them. If you drew a hexagon and the lines that included the sides of the hexagon, would the relationships between the angles at each vertex be the same as those in the pentagon? What do you think? So here's the hexagon. I can do the same thing. And yes, they would be the same. We got one interior, three exterior angles, so yes. Okay, so what you're going to learn in this lesson is we're going to derive how to figure out the sum of the interior angles of any polygon and the sum of the exterior angles of any polygon. And that is the focus of the lesson. So let's go to example 1. So explore the polygon interior angle sums. How does the number of sides of a convex polygon, n, relate to the sum of the measures of its interior angles? So let me pause here and then explain the word convex. Okay, so I'm just going to flip to the other page. Convex polygon. Convex polygons, if you extend any side of a polygon, the line will never go inside of the polygon. So this is a convex polygon because you can extend the lines on any of the sides. It's never going to go inside. So that's a convex polygon, and that is what we're interested in this lesson. Okay, the opposite of convex is concave. Concave polygons, if you extend any side of the polygon, the line will go inside inside the polygon. Whoops, I'm missing a T here. Okay, so if you extend this line, for example, then it goes inside. If you extend this line, it goes inside. So once this happens, it's concave. Okay, we are interested in convex. All right, so let's go back to example 1. So how does the number of sides, which is n, okay, so n is our number of sides, relate to the measures of its interior angles? So we know n is the number of sides. Okay, how many sides do we have here? So what is n equal to here? Well, we got 3 sides. Okay, and how many triangles do we have here? Well, we got 1 triangle. Okay, what is the sum of the measures of the interior angles of a triangle? Well, it's 180. So to see the pattern, what you're going to want to do is pick any vertex that you want. Just pick one of the vertices and draw diagonals to all of the other vertices. So draw lines from this vertex to all the other vertices in the polygon that you see. And then you want to figure out how many triangles you can form, and then see if you can derive a formula or see if you can derive, see the pattern between the number of sides and number of triangles, and from there come up with a formula for how to come up with the interior angle sum of a convex polygon. So you can pause the video and take a look at that, investigate that. Okay, so here I have n equals 4, so I got 4 sides. I'm going to choose this vertex and then draw a line here, and I formed 2 triangles. So now I have 2 triangles. Okay, and then this is 180 degrees and this is 180 degrees. So the sum of the measures for the angles inside the 4-sided figure has to be 2 times 180, because there's 2 of them. Okay, let's do the same thing here. So n here is 5. And how many triangles can I form? Let's see, I'm going to go with this vertex. Here's 1 triangle, 2 and 3. I got 3 triangles. Each measures 180 degrees. The interior angles in each measure 180 degrees. Okay, likewise for this is n equals 6, 6-sided. So it's a hexagon, 1 triangle, 2 triangles, 3 triangles, 4 triangles. What do you notice about the number of triangles as opposed to the number of sides? Yes, you are correct. It's always 2 less. Okay, the number of triangles is always 2 less than the number of sides. Okay, and then this one, we'll just do it since I have it. This is 7-sided. 1, 2, it's going to be 5 triangles. 1, 2, 3, 4. 1, 2, 3, 4, 5 triangles. So generalizing, if you have n sides, you're going to have n minus 2 triangles. Okay, so the sum of the measures of the interior angles of a convex polygon is therefore 180 times the number of triangles. Okay, namely, it's going to be, and we know the number of triangles, we want to relate that to the number of sides, okay, of the polygon. So it's going to be 180 times the triangles is always 2 less than the number of sides, so 180 times n minus 2. And that's how you calculate the sum of the measures of an angles inside a convex polygon. Alright, let's look at the triad. How many triangles are formed by drawing diagonals from a vertex in a convex octagon? How many sides is octagon? It is 8 sides. How many triangles can we draw? 6 triangles. What's the interior angle sum for a convex octagon? Well, the sum, therefore, is going to be 180 times n minus 2, which in this case, n is 8 minus 2. So that's 180 times 6, which is 1080 degrees. So the interior angle measures of a convex octagon is 1080 degrees. Okay, so here is the theorem for what we just came up with, the polygon angle sum theorem, which tells us the sum of the measures of an interior angles of a convex n-gon is 180 times n minus 2. Okay, so in this example, angle 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, because we have 7 sides, equal 180 times 7 minus 2, which is 180 times 5, which is 900. Okay. Pause the video and see if you can do the additional practice 1, 2, 3, and 3, 4, and 5, and then come back and check your answers. Okay. Find the sum of the measures of the interior angles of a convex hexagon. So n equals 6 here. So this is 180 times 6 minus 2, so equals 720 degrees. Okay. For number 2, it tells us the sum of the measures of the interior angles of a convex polygon is 1,260 degrees. Our job this time is to classify the polygon by the number of sides. So we are finding n. Okay, so we need to work backwards. I know the sum is 180 times n minus 2. Okay, so I'm finding n here, but I know the sum. That's 1260 equals 180. I'm just going to distribute this, so 180n minus 360, and then we solve for n. Okay, so we get 180n. Add 360 to both sides, you get 1620. Okay, and then divide by 180, and we get n equals 9, which is a nonagon. Okay. Find the value of x in the diagram shown. Well, we have 4 sides here, so n equals 4. Therefore, I need to find the sum of the interior angle measures, and then I can subtract from there to get x. Okay, so this is 180 times 4 minus 2, which is 2, and I get 360. Okay, and then I add all these up. So x plus 71 plus 135 plus 112 must add up to 360. Do the algebra, and x will calculate to 420 degrees. Okay. Find the sum of the measures of the interior angles of the convex decagon. Decagon is 10-sided polygon, so n is 10. So that's 180 times 10 minus 2, so 180 times 8, which is 1,440 degrees. Okay. Use the diagram at the right. Find the measurement of angle K and measurement of angle L. Okay, so 2 things to observe. You notice that K and L have congruent markings, so they are congruent. So let's call them x here. Both of these would have to be x degrees. Okay, and then we need to figure out how many sides we have here. So we have 1, 2, 3, 4, 5 sides. So n equals 5. Okay, so the sum of the interior angles is therefore 180 times 5 minus 2, which is 3. And we get 540 degrees. So now take 540, subtract all of these. So we have, so the equation is 68 plus 105 plus 109 plus x equals 540. So solve that, you get 2x equals 258. I'm skipping the detail of the algebra here. And then x equals 129 degrees. So this is equal to the measurement of angle K and then measurement of angle L. Okay? Alright, corollary to theorem 6.1. So it follows from the previous theorem that the measure of n1 interior angle of a regular n-gon is therefore the sum of the interior measures divided by however many sides we have. This gives you the measure of one of them inside. But here's the very important part to note here. This corollary only works if you have a regular n-gon. Okay, only a regular n-gon. And here we're talking about the sum of one interior angle of a regular n-gon. What does regular mean? Regular mean we have congruent sides and angles. Okay, so this works only if you have a polygon that has congruent sides and congruent angles, the same sides and angles, as in this one. So n is 5 here, this is a pentagon. So if we have a pentagon, a regular pentagon, and I ask what is the measurement of angle 1 and 2 and 3 and 4 and 5, they're all the same. How do you calculate that? You take the sum of the measures of the interior angles of a polygon, divide by however many angles we have. In this case we have 5, because we have 5 sides, so we have 5 angles. And then you get 108. So therefore each one of these angles measures 108 degrees. Okay? Alright. Let's flip to the next page. These are some examples, not necessarily regular polygons. So So let's take a look at example 2. Jenna is building a cabinet to fit in the center of a rectangular room. If the two angles marked X here must be congruent, what are their measures? Okay, so that they redrew the top for us here to make it easier to look at. This is 90, 90, and this one is 90 degrees by the marking. Okay, and we have a 5-sided figure, 1, 2, 3, 4, 5. So n is 5. Okay, so in order to calculate x, this is similar to the previous problem that we did here, similar to this one. So figure out calculate the sum of the interior angles, which is 180 times 3, which is 540. Okay, then you take 90 degrees, there's 3 of them, so 3 times 90 degrees, and there's 2 x's. All of those must add up to 540 degrees. And then you just solve for x here. Okay. So x equals 135 degrees and 135 degrees. Okay, another question. What is the interior angle sum of a 17 gon? So 180 times 15, 17 minus 2, and we get 2,700 degrees. Okay, here's an application of the regular. So each angle of a regular n-gon measures 172.8. We want to figure out how many sides the n-gon has. So I'm just going to use the equation in here, reason through it, the equation in this theorem, the corollary. So we know that each angle of a regular polygon can be calculated by taking the sum of all of the interior angles divided by however many angles there are, which is the same as number of sides, which is n. Okay, and then work backwards. Well, in this case, each angle is 172.8. The sum is going to be 180 times n minus 2. I don't know what n is, that's what I'm solving for, divided by n. So this is your equation. So let's solve this equation. We're going to get rid of the fraction here by multiplying both sides by n. Okay, so that's my first step. And I'm also going to distribute this. So we get 172.8 n equals 180 n minus 360. And then solve for n, so subtract 180 n from both sides. You get negative 7.2 n equals negative 360. And of course, when you divide by negative, then you get a positive number of sides as expected. So this is a 50 gon polygon. Okay? Now that we know how to calculate the sum of the measures of the interior angles of a convex polygon, let's look at the sum of the exterior angle measures of a polygon. Okay? And we're going to start by taking a look at the regular polygon drawn. And this polygon, what is the name of this polygon? Yes, it's a pentagon, it's 5 sides. Okay, how many sides does the polygon have? Well, it has 5 sides. This is just to walk you through deriving the sum of the exterior angle measures. So let's do it one step at a time. What is the sum of the interior angle measures? Well, you're going to take the 180, the interior angle measures. So 180 times 5 minus 2, which is 3. And it's 540 degrees, which we already calculated twice from the previous examples. Okay, now we want the measure of each interior angle. So you're going to take 540, the sum, and you're going to divide it by 5 because there's 5 angles, and you're going to get 108 degrees. So each one of the inside angles here measures 108 degrees. Okay, each one of these is the same inside. Okay, how would you find the measure of angle 1 on the outside here? Well, notice that 1 and 108 form a linear pair. So you're going to take 180 and subtract 108, and you're going to get 72 degrees. So this one is 72 degrees. So is this one. So is this one. All of them, because all of the inside is 108, so all of the outside is 72. Okay, so let's generalize. How would you find the measure of all of the numbered angles? So 1, 2, 3, 4, 5, the ones on the outside. Okay, you're going to take 180 degrees, because they all form linear pairs with the interior. This is a linear pair. This is a linear pair. This is a linear pair. So is this. So is this. Okay, so we can take 180 degrees minus each interior angle, which is 108. Then there's 5 of them in this case, so I'm going to multiply by 5. And that calculates to 360 degrees. Okay? The observations here that we make, we want to generalize that to any polygon. Well, each interior angle forms a linear pair with each exterior angle forms a linear pair with each interior angle. Therefore, the sum of the measures of each exterior and interior angle pair, so now I want the sum of all of them, all the pairs together. Okay, so each pair is going to have to be 180 degrees. How many exterior angles are there? Let's generalize and put n. In this case we have 5, but I want to generalize it. Therefore, the sum of the exterior angle measures, remember our focus is we want to figure out only the sum of the exterior angle measures. And this works for any polygon now. Not just regular, but any polygon. I just gave you a regular example to derive it. Okay, so the exterior angle measures, you're going to take, to figure out the exterior, take the 180 and subtract the interior. But I'm going to do it for all of them. So it's the sum of the interior and exterior angle measures, which is 180. How many of those angles do we have? Well, in this case we have 5, but generally for any polygon we have n. There's n linear pairs. That's what this is saying for any polygon. You're going to subtract the interior angle measures. Okay, what do we know about the sum of the interior angle measures? We already know that. That's 180 degrees times n minus 2. Okay, so basically what this is saying is take the 180, subtract the interior, and then you get the exterior. But then we're doing it for all of the angles. That's why I have an n here. Okay, for each linear pair. Let's work this out. Simplify it. Minus 180 n plus 360. Negative times a negative is a positive. 180 n minus 180 n is 360. So yes, the sum of the measures of the exterior angles of any polygon is 360 degrees. Always. Does not matter regular or not regular. It's always 360. Which is this theorem. And if you want to look through this, you're welcome to. That's just what I just walked you through in the previous. It's the same idea as this. Okay, so the sum of the exterior angles of any convex polygon is 360. Again, we're still talking convex, but regular or not, it equals 360. All right, let's try it. What's the sum of the exterior angle measures of a convex 17gon? 360 degrees. How about a hexagon? 360 degrees. How about a pentagon? 360 degrees. All right, here it is again. So that's a theorem. 360 degrees. Okay, let's do some practice problems. You can pause the video and try these and then come back and check. Okay, Remember also, these are all worked out and scanned, and I have the notes worked out on Canvas. So you can always look at the worked out notes as well. All right, suppose angle 1 is congruent to angle 3, and measurement of angle 1 is 3x. Okay. So 1 is congruent to 3, and 1 equals 3x. Therefore, 3 also has to equal 3x, because they're congruent, because that's what they told me. Okay, and measurement of angle 2 equals 2x. All right, so this one is 2x. What is the measure of each exterior angle? Okay, well, I see this one is 90, so 5 has to be 90. This angle is 90, so 4 has to be 90. So you're going to add all of these exterior angles and set them up to equal 360 and then solve. So we got 3x plus 2x. I'm just going to go in order. Angle 1 plus 2 plus 3 is 3x. Plus 4 is 90. Plus 5 is 90. All of these exterior angles add up to 360. And I'm going to skip the algebra part, do the algebra, and then x will be 22.5. Therefore, measurement of angle 1 is equal to measurement of angle 3, and that is 3 times 22.5, which is 67.5 degrees. And then measurement of angle 2 equals 2 times 22.5, which is 45 degrees. Okay. Okay, let's look at this example. Suppose angle 1 is congruent to angle 3, is congruent to angle 4, and congruent to angle 6. Okay, so all of these are congruent. Let's call these x. We're going to give them x. So 1 is congruent to 3. All of these are x's, and then 4 and 6. Okay. And then 2 is congruent to 5. Okay, so 2 is congruent to 5, and measurement of angle 3 is measurement of angle 2 plus 30. Okay, so I want to figure out the measurement of angle 2 in terms of measurement of angle 3. So I want to solve here for measurement of angle 2, because I want to write it in terms of x. Measurement of angle 3, I already called it x. Okay, so let's get measurement of angle 2. So that's going to be x minus 30. Okay, so I know that 2 and 5 are congruent. So now I can label number 2 here x minus 30, and 5 is also x minus 30. Okay, so I got an expression for all of the exterior angles. So now I'm going to go in order and then set them up to equal 360 and then solve. So we have x plus x minus 30 plus x plus x plus x minus 30 plus another x equals 360. Okay, we do the algebra here and I get x equals 70 degrees is when I did this. Okay, which is measurement of angle 4. So 1, 3, 4, and 6 are 70 degrees. And then 2 and 5 are 40 degrees. Okay, so the 70 minus the 30. Okay. Find the measures of the interior angles. What are the measures of the interior angles of the pentagon? The interior angles of the pentagon. So n is 5. So now we're back to 180 times 5 minus 3. Okay, which is 540 degrees. And then yes, you're just going, this is 90 degrees. So just add all of these up. So 3x plus 4 plus 7x minus 3 plus 6x plus 12 plus 90 plus 6x minus 3 and set them equal to 540. Like so. And then do the algebra and then x will be equal to 20. Once you know x is 20, then you can plug that 20 back in and find the measures of each of these angles. Okay? Alright, the last one. The measure of each interior angle of a regular 100 gone is 3x plus 26.4. What is the value of x? Okay, here we're talking interior angles. Okay, so we can do it in one of two ways. Just going to show you how I did it. So either using the interior angle or the exterior angle. If I do it using the interior angles, we know each equals the sum over n. So then I plug in the information I know. Each here is 3x plus 26.4. The sum is 180 times 100 minus 2 over 100. Okay, and I solve for x. I can solve for x here. So multiply both sides by 100 to the algebra, and I got x equals 50. Okay, another way we can do it is using the exterior angles. Okay, I know that each exterior angle of that 100 gone, you're going to take 180 and subtract the interior angle. So 180 minus 3x plus 26.4. Okay, and I know that there's 100 of them, so 100 times each one of the exterior angles must equal 360. Okay, so then I plug in the information that I have. So 100 times each exterior angle, which is given by this expression, equals 360. Then I solve this, and beautifully I get the same x value, which as I should. All right. Your homework is here. All right, and that's all I have for you. Have a good day. Thank you. Bye.